So this is the first lecture of the NMR spectroscopy, and I will teach you the basic concepts of NMR spectroscopy, and then we will go to the advanced course of the NMR spectroscopy. So there are several million of organic compounds that have been identified, and thousands are prepared each year. 90% of the organic compounds are synthesized in the laboratory while rest 10% are from the natural resources. To identify all these compounds, we need some special techniques like spectral analysis. Spectral analysis is used to identify the compound, because when we synthesize a compound in the laboratory or we extract a compound from any natural resource, then we have to identify its structure. What is the structure of the compounds? How many carbons, hydrogen, oxygen are there? There is a single, double or triple bond in the molecule. So in order to do this, we have different techniques. So the advancement in the spectral analysis also tells us that our reaction is complete or not. Like we are doing our reaction in a laboratory, like to synthesize a new compound, and we don't know that our product has formed or not. We can do the spectral analysis, and then we will be able to know that does our product is made or not. Most commonly methods in the organic chemistry are IR spectroscopy. First is IR spectroscopy and UV visible spectroscopy. Mass spectrometry. X-ray analysis. NMR, nuclear magnetic resonance spectroscopy, and elemental analysis. There are 6 different spectral analyses that are very common in the organic chemistry. We will study all the 6. We will discuss the benefits of all these methods and how these vary from the NMR and how NMR is beneficial. Like we can make a compound like ethyl benzoate. Let's take ethyl benzoate. I am going to draw the structure of the ethyl benzoate. So this molecule is ethyl benzoate. Like we will apply all these 6 methods on this molecule, and we will study that how these methods are beneficial to identify the structure of this compound. In the IR spectroscopy, we can identify that there are functional groups in our molecule. Like this is an ester, and there are double bond in the ring. So in the IR, we can identify that there is a double bond, and there is an ester group in our molecule. You know that the double bond is also a functional group. And in the next second number is UV visible spectroscopy. It is used to identify the conjugated compound. Like we can identify that there is a benzene ring conjugated with the some other system. Like this is a benzene ring and it is conjugated with the some of the other system. So let's move now on the third step. This is mass spectrometry. Mass spectrometry gives idea about how much is the mass of our molecule. Like we can count that how many carbons are there. So there are 9 carbons and 10 hydrogens and 2 oxygen. So I can calculate the mass of our compound, and it is almost 150 AMU. So in the mass spectrometry, we can know that the mass of our molecule is 150 atomic mass unit. Mass spectrometry gives also an idea about the structural fragments of the molecule. Like in the mass spectrometry, we can cut this structure. Like it gives an peak. Like this mass is 15, 12 for the carbon and 3 for the hydrogen, 15 AMU. And it will give a peak in the spectra that there is a 15 atomic mass unit fragment in our molecule. It can also do the fragment of this part of the compound. Like this is 15 for the CH3 and then 14 for CH2, and this is 29. It can also give a peak of show the peak of the 29, and this is for the 15. It will show first of all it will show a peak of the 150 atomic mass unit. This one 150, sorry. So this is a peak 150 atomic mass unit. So it will give a peak for the benzene ring as well, and we can see that there are how many fragments are in our molecule. High resolution mass spectrometry gives an idea about that what is the formula of our compound. It will not give the structure formula, but it only show there are 9 carbons, 10 hydrogen and 2 oxygen based on the mass of the fragments. So this cannot be the exact compound, but the software that we used for the mass spectrometry gives different idea about this, maybe C9H10 O2 or this. So let's go to the X-ray analysis. X-ray analysis is very useful technique to identify the structure of the compound, but we need the single crystal of the molecule. It is a demand of X-ray analysis. X-ray analysis is also very tedious, time taking, but it is also very beneficial that we can identify that how much angle is between the bonds and how much is the bond length of carbon and oxygen and carbon, and this carbon and hydrogen, and this is a very useful technique. We will discuss NMR on the last. Let's discuss the elemental analysis. In the elemental analysis, we know that the quantity of an element in our compound. So it is also very useful. And let's come to the NMR. NMR is known as a nuclear magnetic resonance spectroscopy. It is a very useful technique. In this technique, we know that we can identify that our compound is pure or not. Like we know that this the spectra of the original compound, and we can take like we delivered a new compound like from any company, and that we want to know that what is the structure of the compound, and it is pure or not. How many peaks are there, how many carbons are there, how many hydrogens are there. So we can do the NMR for that compound. We can also check that our compound that we are doing a reaction in the laboratory, and we can also identify that our product has made or not. Next, we can identify the carbons in our compounds. How many carbons? Like 1 2 3 4 5 6 7 8 9 carbons. So in the carbon 13 NMR, we can also identify that there are how many carbons in our compound. We can also get the information about the neighboring hydrogen. Like there are 3 hydrogens, we can also identify that how many hydrogen are in the neighbor of these 3 hydrogens. Like there are 2 hydrogens in the neighborhood. Like if we are going to see this peak, we can also identify that there are 3 hydrogen in the neighborhood. So in that way we can get the information about all the neighboring groups as well. So this NMR technique is very useful to identify the structure. In all other techniques, it is very difficult to know that which one is the neighboring group of our fragment. Like CH3 fragment in the IR, we can get the information about the functional group, but we don't know that our functional group is attached to CH2 or CH3 or benzene ring or whatever. So NMR has this priority on all the other methods. So let's go on the next page. NMR. There are 3 types of the NMR: liquid NMR, solid state NMR, and NMR like imaging. Like maybe you know that about the MRI, magnetic resonance imaging. Liquid NMR. In the liquid NMR, we dissolve the compound in the deuterated solvent, and we get the 2D, 1D, or 3D spectra of that compound. But it is difficult to study the 3D spectra to understand that one-dimensional spectra is simpler than 2D, and 3D is the most difficult to study. So next is we can take the spectra of all these compounds. Like we are studying a compound, we can get 1D, 2D, and we can study that. One-dimensional spectra is the most easy one, then the 3D spectra. So liquid NMR is very common one, and then we come to the solid state NMR. Solid state NMR is very beneficial, and it gives us the more information than the liquid NMR. Because in the liquid NMR, when we dissolve our compound, its neighborhood is affected, but in the solid state NMR, it is not affected, and we get the more information. But to study the solid state NMR spectra is difficult than the liquid NMR. It is very difficult to identification of the peaks. We need a skillful person who can identify the spectra of the solid state compound. Next is the MRI, magnetic resonance imaging. It is based on the same concept of the NMR, but our material is different, like bones, tissues. So the solid state NMR and the liquid NMR are the commonly used in the lab, but MRI has many applications in the bio, and it is used in the hospitals or in the laboratories to study bones and tissues. So I think it is enough for today. We will discuss more about the NMR in our next lecture. Thank you. If you like this video, please subscribe my channel and also like this video. Thank you.